Okay, now let's look at another one that's slightly different. We're going to graph this system here. We have a absolute value function, um, and then we have another linear. So let's start with the absolute value. All that's happening here compared to the parent function is that it's being shifted to the right one. But as far as like each of the branches, it's going to be the same as the parent function. So the right side is going to have a slope of 1, the left side is going to have a slope of -1. So we're just going to shift right 1 on the origin. It's not going up or down. So and we go up 1 over 1, up 1 over 1, up 1 over 1. And then this side, left 1, up 1, left 1, up 1, so forth. And it's greater than or equal to. So that means we're going to use a solid line. So it's going to look like this. And this. Now we ask ourselves, which side do we shade? Well, it says that y is greater than or equal to. So we ask ourselves, well, which direction is y greater than? And that's up. So we shade above the function. So that's going to be everything above it. So that's going to be all of this here. Okay. Now, let's graph the next one. Now this one is linear. There's no y value, it's just x is greater than 2. So recall that if you have just x is equal to a number, that's going to be a vertical line with an undefined slope. So, and we're going to be using a dashed line. So let's see, we're going to start at 2, so all the values of x should be 2. And so it's going to be right here along 2. This way and this way. Okay, now as far as shading is concerned, this is going to be the only exception as far as determining how you shade, because you can't shade above or below a vertical line. This is the one case where you're going to consider shading left or right. So we need to think about what it's telling us here, and it's saying that x is greater than 2. So looking at our vertical line, we say, well, which direction is x greater than? Well, it gets greater the further we move to the right. So we're going to shade everything to the right of this line, trying not to cross the line. So it's going to be this whole region here. And this kind of gives you a chance to break out those elite coloring skills you've been developing since preschool. My skills are not elite at this. I've always kind of struggled at coloring because coloring is hard. I can't stay within the lines. I guess it's because I'm such a rebel. All right. So now, we can see that any point in this region here is going to be a solution to the system. It'll work for both. But I want to experiment. I want to test, let's say, a point that is in the yellow region, but on our vertical line. So let me go ahead and I will do, let's try this point here. So this is the point 2, 4. Now it's right on the vertical line. So what I'm going to anticipate happening is it's going to be a solution for the first inequality for the absolute value because it's well in the yellow region, but it won't work for the other line because it's a dashed line, and so anything that's dashed, any point on the dashed line is not a solution. It has to be solid for that to work. But let's verify this. So we'll start off with the absolute value. So 4 is greater than or equal to 2 minus 1, the absolute value of 2 minus 1, and 4 is greater than or equal to, so this is going to give me the absolute value of 1, which is just 1. So 4 is greater than or equal to 1. So that clearly works, as we anticipated. Now the next one, I'm going to substitute this into the x. Now there is no y, so the only thing I can substitute into there is the x. So 2 is greater than 2. Well, 2 is not greater than 2. That does not work. So that would not be a solution for the second inequality. Now, had this been a greater than or equal to, then we would have drawn a solid line, and then we've said, oh, okay, well, yeah, that's a solution. So that's why we use a dashed line versus a solid line for those points that are on the line itself. Anyway, that concludes graphing systems of inequalities, and I'll see you in the next video.